Name of subject: internal combustion engines. Name of chapter: SI engines fuel supply system, ignition system, combustion. Name of topic: spark ignition engine mixture requirements, fuel air ratio. Contents: spark ignition engine mixture requirements, fuel air ratio. Directed to notes to understand the further part in detail. Dear friends, in the last video, we already started to discuss about the carburetor and its detail. So we discussed that petrol is one of the major fuel which we are using in SI engine or petrol engine, which is a combination of different hydrocarbons like paraffins, olefin, naphthalene, aromatics, etc. etc. Okay, so why we are using petrol as a fuel in SI engine? Because it has few specific properties, and that properties are very much required in the case of petrol engine or in the case of spark ignition engine. Okay, someone can ask one question: why we are not using kerosene as a fuel in SI engine? Why we are not using diesel as a fuel in the case of SI engine? Why only we are using petrol or a gasoline as a fuel in a SI engine? Because of a following important reason. Okay, so why? This question is very important. Why only petrol for SI engine? Many of times, if you observe sometime because of some mistakes, if in petrol engines, because of mistakes, some diesel fuel will be there. So the engine will not run in that case, and time being we have to remove that particular diesel from the petrol engines. Okay, so why such kind of things are there? So always remember, my dear friends, SI engines are specially manufactured or produced only for petrol or gasoline as a fuel. So why only petrol or gasoline as a fuel for SI engine? This question is again important. So here you will get the answer of this. SI engine has some specific fuel requirements, and these requirements only fulfilled by the petrol or gasoline. That's why this is one of the major fuel of SI engine. So what are those requirements? Here we are going to discuss. Following are the basic requirements of SI engine fuel. Okay, so what is the first requirement of SI engine fuel? The first requirement is it must evaporate quickly when injected by the carburetor in the current of air. That is again very important. So when we use a carburetor as a device to supply the amount of air and fuel mixture inside the engine cylinder, that time this characteristic or this requirement is very essential. If sometime what happen, when the air and fuel mixture will supplied by the carburetor and that is not able to burn inside the engine cylinder, then think what will happen. Yes, so that's why whatever fuel we are using in the case of SI engine, that should be evaporate quickly. Evaporation is one of the important property of the petrol. If you consider one example, when you keep open petrol to the atmosphere, after some time its volume, if we check the volume of it, some kind of volume will get reduced. This happens only the evaporation takes place. The evaporation because the petrol is open to the atmosphere. So the petrol or gasoline is one of the important property, that is the evaporation, and that is the first basic requirement of SI engine fuel. Okay, one by one we'll understand this all basic requirements of SI engine fuel. The second one, it should not pre-ignite. That is again very important. Petrol is one kind of a fuel which will never pre-ignite until and unless its burning temperature will reach or combustion temperature will reach. Okay, so this is one of the requirement. It should not pre-ignite, and so the petrol will not pre-ignite. So it fulfills the second requirement. That's why we are using petrol as a fuel in the case of SI engine. So similarly, the third requirement of SI engine is what? It should be easy to handle. Yes, definitely. If you take the example, if wherever you are living now, suppose XYZ city is there, you are living in Mumbai right now, and suppose the petrol is coming from Chennai. Is it right? So the transportation is very much easy through the railways, through the road transportation. Such kind of things are present to transport the petrol. And again, if you compare these things with the mercury, I think all of you are knowing about the mercury. So it is very much difficult to handle even. So that this is the one of the important parameter or requirement of SI engine fuel. It should be easy to handle, and petrol is very easy to handle. Okay, the fourth one, it should be easily available at reasonable cost. Yes, right now I don't know is it at reasonable cost or not, but though this is one of the requirement, it should be easily available at reasonable cost. Yes, if you compare this one along with the cost of gold, 1 liter petrol near about 100 rupees per liter right now in our Indian market, and the 10 gram of gold cost is near about 50,000. Is it right? So always remember which fuel we are using in case of SI engine, that should be affordable. Its cost not that much high. Okay, just consider the gold is one of the example to compare the price of it. Okay, so similarly, gold is not the fuel, gold is another thing, and petrol is another thing, but only I have given this example to understand the cost effect. Okay, that should be always reasonable. The next one, fifth requirement is what? It should burn clean and should not deposit residue. So always the petrol will burn clean. If you check, very less amount of exhaust gases will come out after burning of the petrol as compared to other fuels like kerosene or diesel. Okay, so this is the one of the requirement. It should burn clean and should not deposit residue. Residue means what? After the combustion, some kind of remaining things are present over there, and that is like carbon composites or carbon contents like that. So it should not deposit any kind of a residue. Then next, its exhaust should not have any corrosion effect on the engine part. This is again very important. Few fuels are there, it always reacts with some metal parts, and because of that reaction, the corrosion effect will happen on the different components. So this should not done in the case of SI engine. So this is the another requirement. And the next one, it must have high calorific value. Calorific value should be high whatever fuel we are using in the SI engine. Okay, so it should be always high. And the last one, it must be knock resistance. Okay, so later on we have to talk on this, we have to discuss on what is the meaning of knocking or knocking tendency. Later on we'll talk in detail about this. Okay, so these all are the requirements of a SI engine fuel. Okay, so all our requirements are mostly concerned with the physical and chemical properties of fuel, and that properties likely volatility, chemical structure, sulfur and gum content. So we can say petrol is a only fuel which fulfill all these requirements of SI engine fuel. That's why we always use petrol or gasoline as a major fuel for spark ignition engine. So this statement is essential. Here we just understood why we are using petrol as a fuel in SI engine with the help of all these SI engine fuel requirements. This question is again very important. In your examination, the question may ask to you, explain SI engine fuel requirements in detail. That time you have to write all these things clearly. Okay, so after this one, the next point which we have to discuss, that is air fuel ratio or fuel air ratio. This is again very important. Now we understood what is the meaning of the process of carburation. What do you mean by the carburetor? Carburation is nothing but the process of mixing up air and fuel before it's supplying to the engine cylinder. And that process is nothing but called as the process of mixing up combustible mixture before supplying to the engine cylinder, and this is called the carburation process, and the device which does this job is nothing but called as a carburetor. Okay, as we discussed in the last video itself. So the next one, the air fuel ratio. So what do you mean by air fuel ratio? We always heard there are three types of air fuel ratio. One is a chemical correct mixture. It is also called as a stoichiometric air fuel mixture. Second one, rich mixture. Third one, lean mixture. So always remember, dear my friends, air fuel ratio is nothing but it is an ratio of air to fuel. Okay, just simple. An engine generally operated at different loads and the speed. For this purpose, the proper air fuel mixture should be supplied to the engine cylinder. Okay, so always we know, if you can take the example of two-wheeler. Sometime on two-wheeler we sit alone, sometime there will be a two-person, sometime there will be a three-person who will sit on that particular single bike. Okay, so in this case the load conditions are different, as well as sometime you are going to ride your bike with speed of 40 km per hour. Sometime if you want to reach some hurry is there, that time you will increase the speed of the engine, speed of the vehicle 80 km per hour. So always there should be a variation in load as well as speed of the engine according to the operation, according to the requirement. So for this purpose, we have to supply a proper amount of air and fuel mixture to the engine cylinder, and this ratio is nothing but called as the fuel and air ratio or air to fuel ratio. Okay, I think all of you are knowing about accelerator is there. Okay, I think many of you are using two-wheelers. Okay, or in the case of two-wheeler, accelerator is there. If you want to increase the speed of the engine, what you can do, you just increase the accelerator, is it right? And automatically the speed of the engine will increase and your vehicle will run fast. Again, if you want to decrease the speed of the engine, what you can do, you just again move the accelerator in reverse direction. Ultimately the speed of the engine will get down. Then how it is possible, how it will happen? This is only happen because of the carburetor which supplies these three different mixture to the engine cylinder. Now here we are going to understand thoroughly what is the meaning of these different types of air fuel mixture. Okay, one by one we'll understand. So we start with the first one, that is a chemically correct air fuel mixture. Okay, so according to the definition of chemically correct air fuel mixture is nothing but it is this, there is a just enough air for complete combustion of fuel. Very simple definition. The chemically correct air fuel mixture is also called as a stoichiometric mixture. In this, there is just enough air is present for complete combustion of fuel. Means required amount of air is present for complete combustion of fuel. That is nothing but called as a chemically correct air fuel mixture. Okay, that's it. So with the help of one example here we can understand what is the meaning of chemically correct air fuel mixture. Suppose we want to burn 1 kg of octane completely. So what do you mean by octane? Octane is one of the content in petrol. Later on we will discuss about the octane. Just you consider octane is one of the member which present inside the petrol, one of the chemical composition which present in the fuel. If the octane number is high, then we can say the petrol quality is very good. Okay, so in this case, if suppose if you want to burn 1 kg of octane completely, it required 15.12 kg of air. Means suppose if you can take the example of coal, if you want to burn 1 kg of coal, you required 15.12 kg of atmospheric air or air. Similarly over here, for burning of 1 kg of octane, here we required 15.12 kg of air, and this ratio is nothing but called as the chemically correct ratio. Chemically correct air fuel ratio means proper amount of air is present for complete combustion. Means combustion will be done completely, no any kind of residual things are present after the combustion or will present after the combustion. Okay, so how we can write this? 15.12 kg of air and 1 kg of fuel. That's why the air fuel ratio was 15.12 as to 1. What is the air fuel ratio? Simply we can write that is 15 as to 1 is the air to fuel ratio. This 15 indicates the value of air, that is 15 kg, and 1 kg indicates the value of fuel. So we can write 15 as to 1 is nothing but the standard stoichiometric or chemically correct air fuel ratio for the octane. Always remember this value 15.12 as to 1 or just 15 as to 1 is a chemically correct or stoichiometric air fuel mixture. Hope you understood the meaning of stoichiometric or chemically correct air fuel mixture. So the next one that is again too important to understand, that is a rich mixture. So please concentrate on the spelling of the rich. Rich is not R-E-A-C-H. Here is R-I-C-H. Rich mixture. So first of all, we'll see the definition. A mixture which contains less air than the stoichiometric required is called rich mixture. Okay, as we just discussed, 15 kg of air is required for burning of 1 kg of octane completely. But in the case of rich mixture, a mixture which contains less air than the stoichiometric requirement, means in the case of rich mixture, the amount of air should always less than 15 kg, and that all ranges are nothing but called as a rich mixture. So with the help of this example, we can understand rich mixture how we can get if this value is get reduced by 15. So here 12 as to 1, 10 as to 1, water values less than 15 for the air, this all comes under rich mixture, And my dear friends, if you want to increase the speed of the engine, that time you should have to provide rich mixture to the engine cylinder with the help of the carburetor. And how carburetor will able to supply the rich mixture? It reduces the amount of air than stoichiometric requirement, and it will never reduce the amount of fuel. Someone might get some kind of a confusion in their mind. In the case of rich mixture, there is always reduction in the air. There will be a not increment in any kind of a fuel percentage. Okay, but by default, if we are going to reduce the percentage of air, so ultimately the mixture will be too strong for the combustion purpose. That's why the mixture will be a rich mixture. So 12:1, 10:1, 13:1, 14:1, all these things comes under the rich mixture. Okay. So after the rich mixture, the next one, the last type is a lean mixture. So what do you mean by the lean mixture? So lean mixture is nothing but a mixture which contains some more air than a stoichiometric requirement is called lean mixture. So as we just seen, the stoichiometric requirement is 15. If the mixture is nothing but more than 15, okay, the amount of air is more than 15 kg, then it comes under the lean mixture. Means whatever things or whatever air percentage is more than 15 kg, that is 16, 17, 18, 19, 20 as to 1, this is nothing but called as a lean mixture. Okay, so always remember, lean mixture means what? If you want to reduce the speed of the engine, whatever mixture sending by the carburetor inside the engine cylinder, it will be a stoichiometric mixture or it will be a lean mixture. Suppose you are going to ride your bike at a constant speed, maybe 30 or 40 km per hour. That time the mixture which is supplying by the carburetor, that will be a lean mixture where the amount of air is more and there will be again no change in the amount of fuel, but ultimately the amount of air as increases, the lean mixture will supply to the engine cylinder. And my dear friends, your vehicle engine always gives the better efficiency when we ride the bike, when we ride the motorcycle, when we ride the two-wheeler with lean mixture, because the atmospheric air is freely available and through the lean mixture we are sending the more amount of air inside the engine cylinder. So with the help of this, we just understood the first one, chemically correct air fuel mixture, and that value is 15.12 kg of air which is required for burning up 1 kg of octane. Then rich mixture, where the amount of air is always less than the stoichiometric requirement, that is less than 15 kg. So whatever air is there less than 15, that comes under the rich mixture. And when we are going to supply the rich mixture, that time engine speed or engine power will be get increases. And similarly, the lean mixture, if you want to ride the bike at a constant speed, at a low speed, and the air volume, or we can say the amount of air is always less than this stoichiometric requirement, that is less than 50. In lean mixture, the value of air is greater than the stoichiometric mixture, that should always greater than 15, that will 16, 17, 18, whatever, that comes under the lean mixture. And always I suggest you should have to run your vehicle maybe on this stoichiometric range and maybe on the lean mixture. Okay, so how you will be how you come to know the mixture is supplying now the lean mixture to the engine cylinder? So that's why there is some indications are given on the motorcycle meter. Some green labels are there. Okay, if you are going to ride the bike in that particular green label, so you come to know the mixture is probably supplying by the carburetor to the engine cylinder. That will be lean or stoichiometric mixture. If you are going to increase the speed of engine near about more than 60 kilometer per hour, definitely the mixture which going inside the engine, that is a rich mixture. Always rich mixture gives the less efficiency but more power, and always lean mixture gives more efficiency but less power. Okay, so this is again very important. So with the help of this diagram we can again understand this is the diagram of air fuel ratio. The question will ask to you explain the air fuel ratio in detail. That time you have to write all these things clearly, thoroughly, and you have to draw this diagram. Okay, what this diagram indicates, this left portion and this is the right portion. So left portion consisting rich mixture and stoichiometric mixture, and right portion consisting, this is about the lean mixture. Okay, in the case of lean mixture excess air is present. In the case of rich or stoichiometric in the case of rich mixture excess fuel is present. Okay, so in this case here is the range is 9:1, here is the range is 15:1, here is the range is 19:1. 19:1 means what? The more air is there, that's why the mixture is lean. 9:1 means what? The more less air is there, that's why the mixture should reach mixture. Okay, and the stoichiometric range is at 15:1. So this indicates these things: stoichiometric range, reach range, lean mixture range. So I hope you understood in well manner whatever things we discussed today. So I think today this much things are sufficient for you in this video. So thank you so much for watching our today's session. Hope it was informative to all of you. Thank you so much.